Hi guys, and welcome to the video on the properties of rectangles and squares. So for this video guys, you're going to be learning to use the properties of squares and rectangles to find missing lengths and angles in those shapes. You're learning this because these are commonly used in construction, and you'll know you're successful when you can find a missing side or angle length with 80% accuracy. So here we go. As always guys, as we go through these properties, feel free to pause and write them down. Take your time. Because I'm going to just kind of go through them a little quickly to save some video length. So, all the properties of a parallelogram apply, which means that the opposite angles are congruent. They should be. They're all equal to 90. Adjacent angles add up to 180. Again, they should. They're all equal to 90. Opposite sides are congruent. So square sides are all congruent, and a rectangles, their pairs are congruent. And then the diagonals bisect each other. So just remember that all of those properties apply. So the first property of rectangles is that in a rectangle, all the angles are congruent to each other and they're right angles. So just know that all the angles in a rectangle are 90 degrees. Second property is that all the diagonals of a rectangle are congruent. All of them. And that means the two long segments AE is congruent to CE, which is congruent to DE, which is congruent to BE. So that's all the small segments. So A to E, the middle point, that half is congruent to all the other halves. In addition, the two long diagonals are also congruent to each other. So AC is congruent to DB. That's it for rectangles. First property of squares is that all the sides of a square are congruent to one another. So that means that a square also meets the definition of a rhombus, so the previous rhombus properties apply, in that the diagonals are perpendicular to each other. So you can see at angle E, I drew in the right angle box, and then also, all these angles, these diagonals, cut the corner angles. They cut each corner angle into 45-degree angle bisected angles as well. The second property of squares is that all angles are right angles, which makes it a rectangle as well. And then that property, because it's a rectangle as well, means that these small diagonals and the diagonals that go completely across the shape, those are congruent. So it's also AE is congruent to EC, which is congruent to DE, which is congruent to BE, and then also AC is the long diagonal is congruent to DB, the long diagonal. So guys, we're just going to go right into properties here. Find the measure of x and then use it to find the measure of angle 1 and angle 2. We know for a fact this angle here is a 90-degree angle. So we can just use the triangle sum theorem to calculate the measure of these angles. And then we also know that a rectangle has parallel sides here. So then this here, angle 2 is also equal to 3x by the alternate interior angle theorem, and angle 1 is also equal to 2x plus 20. So if I do 3x plus 2x plus 20 plus 90, so I'm using the triangle sum theorem because I see a triangle here, here, here with these three angles. That has to equal 180 degrees. So if I just quick add it up, I get 5x plus 110 equals 180. So 5x equals 70. So dividing both sides by 5x equals 14 here, which means that this measurement here would be 2 times 14 is 28 plus 20 is 48 degrees. And then 3 times 14 is 42. 42 degrees. 42 degrees, 42 degrees. Which, since I know these are equal, that means this is 48 degrees up here, or 42. My gosh, I can't. 42 seems to be a number I don't like. 42 degrees here, and this is 48 over here. So I found my missing angle 1 and missing angle 2. What is the measure of AC? So I am being asked to find the measure of this diagonal here, AC. What I do know initially is that this and this are congruent, as well as this and this. So if I can find x and find one of these segments here, that means that I will be able to calculate the measure of AC by adding the two lengths up. So what I'm going to do is just copy 6x minus 4 over here. And then I know that 2x plus 20. So I know that that was a bad drawing. 2x plus 20 is equal to 6x minus 4. And then I can just solve the equation. I'm going to go ahead and shuffle 2x over here to get 4x by subtracting it from this side. So minus 2x minus 2x. Then I'm going to add 4 to both sides. So plus 4 and plus 4. So I get 4x equals 24. So then x has to equal 6. So then if I know that x equals 6, I can plug it into the equation here. 6 times 6 is 36, minus 4 is 32, which means this length up here is also 32, and so is this one, and so is this one. And then AC is equal to AE and EC combined. So AC is equal to 32 plus 32, or it's equal to 64. All right, continuing. In the square below, BD is measured to be 42 inches. So B to D is 42. What is the measure of X in the diagram below? Okay, so I do know that this and this are congruent, and they sum to 42. So I do know that 5x minus 9 and another 5x minus 9 equals 42. And I'm building this off of the idea that DE plus EB would be equal to the segment BD. So that builds my equation. I can substitute my expressions and what I know BD is equal to. So then I just have to solve. I get 10x minus 18 equals 42. Adding 18 to both sides, so plus 18 plus 18. I get 10x equals 60. Dividing by 10, I get x equals 6 in this diagram. So that's it, guys. Rectangles and squares are the last of the quadrilaterals, and they have very specific properties that apply to them. You basically just need to remember they're built in with 90-degree angles. The sides are all parallel. Their diagonals are congruent, and those little halves of the diagonals are congruent. In a square, the diagonals intersect at 90 degrees, and so on and so forth. We'll make sure that we go over all of those and get them on our flowcharts. We can use those properties to find missing angles, sides, diagonal lengths within squares or rectangles. And then make sure that these specific ones, like the 90-degree diagonal intersection and all their angles being 90 degrees, make sure that you don't apply those to rhombus or trapezoids, because rhombus and trapezoids only do not apply to a rhombus trapezoid. They only apply here. So that's it, guys. Thanks for watching this video. I will see you in the next one.